بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله تعالى وبركاته. My name Ahmed Innawi, and I would like to introduce Dr. Ahmed Rassili. He's Moroccan and living in Belgium, where he earned first his PhD in theoretical physics at the University of Liège and conducted his career on R&D in both Department of Electrical Engineering and Aerospace and Mechanics as a postdoc, then a research director and associate professor on advanced manufacturing. He gained a teaching experience working with the University of Liège, the German University of Technology in Oman, and Euromed University, dealing with applied thermodynamic, fluid dynamic, thermal power station, and manufacturing processing for automotive sectors. Since 2016, he started a new career in business development in a research center, mainly focusing on advanced manufacturing, recycling, and waste valorization sector, including other activities such as zero waste, circular economy, energy efficiency, and digitalization. Ahmed Rassili has developed a well-known experience and grant management in European funding programs such ERANET, Horizon 2020, and Cost Action. He is actually a research director and business developer and European Climate Past Ambassador. Dr. Ahmed Rassili, thank you for, first of all, for being as a member of the virtual university. And I know that you are willing to give a course, a syllabus on your topic where you will talk today. And I will give you the floor now, and I want to thank you very much for your commitment. So I will leave the screen for you, and please go ahead.
Okay, so thank you so much, Professor Ahmed Innawi, and congratulations for this nice initiatives, which I'm sure it will help because people need this to learn to gain knowledge, and mainly on those topics who are really related to our daily life and our future within this planet. So my talk of today, I entitled it From Urban Mining to High Added Value Products, just to show that we can really change our vision of waste and give it really a value if we think only in an economic point of view. But there are many other aspects that we treat. But my syllabus will be on integrated waste management and mainly the case of metals. I'm not specialist in plastics and other materials. I will concentrate on the topic of metals. So let me first introduce, say, my talk within this saying from Greta Thunberg. Everybody knows Greta Thunberg since now. And she says the climate crisis has already been solved. We already have the facts and the solutions. All we have to do is wake up and change. And I would like just to draw, let's say, and stress the 4 words: facts, solutions, wake up, change. And because too simply, there is no planet B. And for other version, there is no plan B. We definitely reached the limit where we have really to change our mind and the way of working. So the first fact, and everybody knows these are the results of our, let's say, the CO2 emission within the world. And you see that huge increase in less than 1 century, really huge. We reached 35 billion tons of CO2 emission. This is fact 1. The slides don't move that. Okay. And the fact 2, in terms of minerals and materials, we notice that we are using minerals and metals in greater quantities than ever before. And this is only for 2 reasons. which are, let's say, suspected for these changes. First is the increased global population, and CO2 emission is also linked to that, and the spread of prosperity across the world. And if we just make some analysis, and in the light of these trends, it has become important to ask if we can continue to provide the minerals required to meet this demand. And also to question whether our resources will ultimately be exhausted. And I think the modern technologies, everybody knows, we spoke about, let's say, mobiles or whatever. I will give some examples later on. These modern technologies make extensive use of metals designated as critical, like raw materials or others, by various criticality assessments. And now these solutions, what is the solution in terms of materials and minerals? It is increasingly apparent that materials that have been incorporated into products no longer in use, which we call secondary materials or scrap, depending on the user, can provide a valuable supplement to these virgin stocks, because virgin stocks, I think one of the colleagues last week spoke about the mineral resources and so on, and he showed definitely that these resources are not sufficient. Some of others, the solutions could be also like what I will explain here, this EU Waste Framework Directive, and this directive draws the waste hierarchy within society, European here, and it could be transposed to other societies. And this directive sets the basic concepts and definitions related to waste management, including the definitions of waste. We need to know how to classify the waste in order to find the solutions for this waste, and also how to recycle and the recovery of this waste. It requires that waste be managed, one, without endangering human health and harming the environment, without risk to water, air, soil, plants, or animals, and without causing any noise or others kind of nuisance. And finally, without adversely affecting the countryside or places of special interest. If you just check the keywords within these 4 elements, which are the requirements, then you will find the whole earth and human and animals and plants. You will find our earth. And this put certain hierarchy for waste. And the best waste is the one which doesn't exist, no waste, product with no waste. And this is called the prevention. So preventing waste is the preferred option. And going through, there are other steps before the last one, which is not the well-suited. Sending waste to landfill should be the last resort. Means the last resort, you need nothing to do except doing that. And this directive has some targets. And I'm putting the words completely because these are directives. I need to be, let's say, to give exact words that are, this is why you see too much text here. Targets is to comply with the objectives of the directive. EU countries shall take the necessary measures to achieve the following targets. So by 2020, for the 2 first one, the preparing for reuse and recycling of waste materials, such as paper, metal, plastic, and glass. And as I said, I will concentrate on metals. Other colleagues will maybe take care of other materials. From household shall be increased to a minimum of overall 50% by weight. So we are 2020, we are already 2021. So it means this target should have been already realized. And the same by 2020 also, the preparing for reuse, recycling, and other material recovery, including backfilling operation using waste to substitute other materials. So waste is no more seen like waste. It's seen as a substitution of non-hazardous constructions, and demolition waste shall be increased also to a minimum of 70% by weight. And last, and we still have 3 years for that, by 2025, the preparing for reuse and the recycling of municipal waste. This is really important because municipalities are producing a huge amount of waste. If you just have been aware a few years ago with this crisis in even in last elections in the city of Rome, the main, let's say, language spoken by the politicians for their campaign was the waste management, because waste is everywhere. People are producing too much waste. And for this, it shall be increased to a minimum of 55, 60, and 65% by weight for 2025, 2030, and 2035. And this brings us to another solution, because it's not only a matter of, let's say, managing waste. It should be managed in a very, really proper way. So one, we extract minerals. There are a lot of processes to extract minerals. I will show it in details, for example, for the case of aluminum and steel in my course later on when it will start, in order to prepare materials. And then these materials are supplied to materials manufacturers to make component out of that. And from the component, we build the products, and then they're sold to us users, you, me, and let's say humans in general. And then a decision is made here now, before any political decisions. One could think that I borrow minerals and materials from Earth. Maybe, well, I can bring it back by landfilling. Maybe this could be a solution. This doesn't exist. This nature doesn't accept that, simply because of the two time constants. When you extract and create a product, it's a matter of months or even years. It's not maximum. But if you want to run the process in the reverse way, you need millions of years in order to jump from the state of products you put in landfills in order that nature give them a second life. This is really impossible in our case. Then we need definitely to decrease at a maximum this state of landfilling or disposal. And then from this start the rules of what we call the circular economy. And when, as far as the circle is too small and close to the user, then we really respond to the objectives of the circular economy. Why? This is if you just take care of your component and your material, and you go ahead with maintenance and repairing and so on, then definitely you can really reuse your product for a long, long time. And you do not need to extract resources immediately as soon as possible. I remember in the past, when something fell down, and then we just go and repair it and reuse it. There were many shops just for repairing. Now you go to shops, the price of repairing is higher than the price of buying a new one. Then what you do, okay, forget it, buy a new one, and it's new one. And we are really, really, really flashed with published and so on, and we go over it. If you don't manage to maintain it for a long use in a product, then maybe try to recover and reuse of the product, maybe within larger, let's say, reparation or whatever. And then if not, then go through recycling and at least recover some parts to put again within the manufacturers. And finally, if there is no way to go within these three first steps, then we go to this next step, which is the material recovery by going through real recycling of extracting metals, minerals, or whatever. And this, I will speak a lot about this part within my course, within material recovery from recycling. And this lead to my presentation, which is this from urban mining to high added value products. I will show it later within the presentation. And the plan I'm presenting is just a presentation of CRM Group. Yes, better to know what do we have in CRM Group, what do we do, because all what I will present is really linked to this environment and economic aspect, but environment are the leading. I will also focus on circular economy aspects and then speak about this urban mining and go through some conclusion and finally present my syllabus and the lectures. Now, first of all, to speak a little bit about CRM Group. CRM Group has let's say device, which is the vision and innovation with industrial solutions. Where, as you can see, the CRM Group is a Belgian-based research center, continuously growing its competences in many different topics associated to metals. As I will just stress this all the time, we're really specialized on metals. We do lose a small amount of recycling of plastics, but in order to recover some energy. This is witnessed by visuals like our logo. If you see that, but you see that it's toward, let's say, metals. And we also have the approach that always the vision and innovation DNA of our researchers should lead to industrial solution with the support of our partners, since we should all strive together a better future. Our identity is that since 1948, that's the one the CRM was born, and this date corresponded to the Plan Marshall. People who are from Europe know what is the Plan Marshall. Is this, let's say, the big investments on the recovery after the war, and it is called Plan Marshall. And this CRM Group is today the result of merger of several, let's say, institutions, and we are something like 265 researchers working in this research center. Our mission is to innovate. As we said, we are supporting our industry in order to innovate, but not only to innovate in order to gain markets, but also to innovate in order to save energy, in order to save materials, and so on. It is obvious that the mission of research center is for sure to innovate us. There is no doubt on that, but not just by ourselves. Our true mission is to support our industrial members. And you will see the list of these members. I don't know what happened with the mouse. We also envision that this should be done by empowering metals in the societal, environmental, and economic challenges of our world. This is, I like to stress it too much. As we said, we're helping our industrials in order to perform, in order to create innovation, to create new products, new solutions, but also with this mind, respecting the environment and the societal aspects. So our commitment is to innovate, as we said. Our professional conscience, collective intelligence, and scientific independence are key values to ensure to reach these innovation objectives together with our partners. And we remain masters of our identity, pursuing our own new ideas, and so on. Our unique approach is a holistic product process application approach. This is definitely one of the excellence from our side. From lab scale over pilot line to industrialization, I will show. We are offering not only low TRL solution, we are offering also upscaling and pilot lines, because we do have pilot lines for many processes in order to help our industrial really to have a real idea on what happens when industrializing the product. And we are approaching multi-sector approach cross pollination. So CRM is also clear proof that is the worldwide presence of several of our products and our solutions. So as we said, we're working a lot with steel and metal industry, and CRM is everywhere. For example, as far as you see, really, let's say the sky, let's say buildings, let's say the high sky buildings, they are using steel, and 1/2 of the steels used in these buildings is a patent from CRM Group. That means in all over the world, we do have our industrials working with our patents, our developments. And this is really important, the global presence with these activities, as I said, over the world, and unique skills developed by more than 265 engineers, as already mentioned before. Our services, there are many. So research project with extensive experience and assistance in projects called preparation, regional and European, and the Professor Ahmed Nawi already mentioned it, that one of the skills I do have is that helping the industrials lower or our partners to build, let's say, collaboration in European projects. Industrial and technical assistance and senior expertise in material evaluation, prototyping design and realization of simulation test benches, licensing in new in-home developed technologies, and also exclusive advantages thanks to CRM membership. So our industrial partner, you can count here that we have more than 45 members, and you can see that all over the value chain of metals, you have these two big steel producers like ArcelorMittal and Tata Steel, and you have all these companies that are either providing, let's say, goods, or John Cochrane, you may know, NG, either more linked to energy sectors and industrialization. Here you see that some steel producers, some solution producers. We have to cover. We are covering the whole, let's say, value chain of the metallic sector. And we have also more than 350 clients per year. So we are in constant development for our clients, and over 100 small and medium companies within the CRM. Well, like everybody, we need, let's say, grants and financial support to deal with that. And the income is by financing. 88% of our income is really coming from private sectors. And we have only, let's say, grants and national, regional, and also European grants, only something like 12%. Our total income is something like 40 million. Our financial leverage, thanks to these collective research programs, which bring many, let's say, money to do let's say, our research and development activities. So our developments now, and it's really important to mention that this is the axis on which CRM is developed, and this is the vision and innovation with industrial solution, as I mentioned it already. And this axis are process and product application developments, the energy shift, the advanced manufacturing, Industry 4.0 and digitalization, and we also spoke about in one of the presentation last week. This is a really important, let's say, paradigm in order to deal with the requirements of today's life, the circular economy and the construction sector. Our core business is and will always remain the state-of-the-art knowledge and tools to develop, let's say, and characterize metallic materials and the process to produce them, and also to use them depending on the industry. Let me start with the first one. This is why I told you we are really, our DNA is metals, and we are working a lot around metal, and starting from metal production, through metallurgical, let's say, know-how over coating and surface treatment in order to gain functionality. It depends on the application for what could be also for photovoltaics, and I will show later on the pilot lines we do have. To develop the right metal solution or application supported by engineering competence. We are all, let's say, capable of bringing a new product or process really to industrialization. And our modeling and simulation tools available at different stages within the metal sector ensure that our solution is oriented the right direction. As some colleagues already mentioned it, we need modeling in order to save, let's say, extra value of the experiments themselves. And then we do also use the tools of simulations. In practice, for the metal application, yes, we have lab facilities for product process developments, which we can provide a low design, metallic and organic coatings, vacuum deposition, surface treatment, and formulations. We have pilot facilities and homemade engineering for iron and steel making, casting, rolling, annealing, and galvanizing. All these technologies are linked to development of steel and also iron, but also other materials, electroplating, surface treatment, painting, and printing. We also carry out the industrial breakthrough with online measurement, monitoring, cooling. This is more linked to let's say, to Industry 4.0. I told you about these technologies, that is Smilpic and TempCore, which are the technologies for this, let's say, the heat treatment, which are unique and they are patented. And as I told you, 50% of the steel used in construction sector use this patent from CRM. And we have also this technology, which is jet vapor deposition, which is really one of the GVD. GVD, we have reached now some solutions for our partners, which is a unique solution in the world. The GVD, there is only one line to ArcelorMittal here, I think that 4 kilometers from my office here, which is a unique, and we are managing to just to coat with to galvanization with some micrometers, and the result is similar than if we coat with more than that. And finally, this production solution success, innovative sandwich panel, hybrid surface treatment, zinc and magnesium-based coatings, and so on and so on. As we already, I already mentioned it, we have this material knowledge, which is really important in order to guide any experiment or orientation for development of a product or functionality. Have deep, let's say, material physics, physics metallurgy, material selection, library norms. We are equipped of that. In terms of characterization, we have micro to nano characterization, mechanical properties, and analytical chemistry, metallography, and all material constants, and also modeling and simulation, modeling and in-use properties like modeling tools, material evaluation from and assembling corrosion, and then materials and services, that's the evaluating property and on-site analysis, where we do use also non-destructive testing, and we have also expertise in product process homologation flows and defects. CRM is not only that, it's, as I said, a set of platforms. I will just go through a few of them, but I will mainly concentrate on the last one, which will be dealing with circular economy and recycling. The first one is the advanced manufacturing platform, which is one of the specialties CRM has, and the topics here that are most exclusively driven by industrial needs. We do have also, as I said, modeling and design, innovative materials. As I said, we help our partners or our colleagues. We do work a lot with aeronautics and aerospace industry, and they need to develop new, let's say, innovative materials in order to respond to the requirements of today's aeronautics. We are equipped with direct metal deposition. We are also use of repair and manufacturing with the assembly staff, surface treatment, as I said, 3D coating, in-use properties, and then recycling. We definitely try each time, I will show it later on, to close the loop in order, let's say, to provide new materials using the old recycled materials and so on. And in practice, like for the other, let's say, platform, we, as I said, innovative materials. We provide design, casting process, innovative alloys for additive manufacturing. Also, we are promoting multi-technology and hybridization, like optimization of manufacturing technologies for large parts using wire or powder, depending on the need. We require also to post-treatments, development, surface treatment of additive manufacturing parts, which is really important. And then, as I said, repair and manufacturing of industrial parts to improve the durability. As I said, we do now imagine you have a component of few tons, and this component was as there's a, let's say, a damage or something like that. What in the past we did through this one and build a new one. Now industrials just need to repair these big components, because the price of the components is really too high, and it needs repairing. It costs less than building a new one, which is the new one is energy and material consuming. Digitalization, it's also one of the aspects we are really targeting in CRM, and it joins all different kinds of competences in CRM group from different sectors. Digitalization is, well, about Industry 4.0. I will not learn you much about that. As making smart products, we are developing our own sensors. We are developing solutions for control in different sectors, mainly, as I said, steel. And I will show maybe here just well, for example, if you have, this is a roll, let's say cylinders, for example. And these cylinders normally in the past, when it finished after many cycles, it's brought to another shop and to be checked carefully, and just try to detect whether there are some cracks or whatever, and the damage within surface. And if it's the case, it's repaired and brought back. Now with the development of the solution,
we are offering solutions like this tablet, and all technicians of within the shop could directly control the cylinder just after getting out from inside the shop, and then make a close scan directly to the product. We're also developing artificial intelligence for industry. We're developing sensors for harsh environment. And also data analytics, because now we're developing sensors. You need to improve the control, and improving the control, you need to have a feedback from the data you collected. And in order to have this feedback, you need to manage this data in very clever way, a smart way. And this is why we recover to artificial intelligence or data analytics. We are also famous in printed and structural electronics. We are one of the centers that is managing to print electronics within metallic substrate. Because as I said, we are developing metallic solutions, and metallic solutions, sometimes if you want, for example, to draw a, let's say, electronic circuit, you need at least to have a basis which is not conductive. And here we managed to really to do it on a steel sector. This is, for example, if imagine your door car and the number of cables you do have in order to connect for the windows to open the electricity and so on. And here we can print all the circuit within the door itself, the metallic door itself, connected steel. And well, I don't know which of the colleagues already spoke about the new buildings of the future, smart buildings. We are also very active in the future of facade in order to have this facade which are really smart and producing either energy or whatever. For the sector of constructions, we are also very active in that, because as I said, also this is linked to our business, which is steel, and in construction, steel and the metals still have a lot of space. And the main objective of this platform is to promote high performance solutions for the construction market, and at the same time integrate higher demand for green aspects at affordable price into the construction market. Now, this can be based on recycled materials, for example. As I said, we're back to recycling. Everywhere we have to use materials, we try to promote this the vision of recycling it. But also on total cost ownership or dismantling option of a construction. This platform offers specific know-how on solutions for large construction sites regarding the structures themselves. And as I said, we have developed from civil engineering, crash dynamics, building structures, building physics, welding and assembly, tests in extreme conditions, non-destructive testing as already mentioned, water treatment and all this stuff. But all this, I think, will be treated later. For this, we are best class in class design solutions for mature and emerging markets. So for example, for this security, let's say, rails, and these security layers, I think we are present all over the world with our solutions, with the galvanized solutions, and we are developing here structures and modeling in order to cover this part. We follow a disruptive but realistic methodology to find a solution that will make the difference of business and encourage new designs to enhance the future. We have, as I said, advanced numerical simulation for ultimate optimization, but here is linked to the construction sector. We have also test rigs, also clean in extreme condition, either fire or cryogenic or whatever, and solution for on-site assembly and erection operation, which is also one of the purposes of CRM. For the energy shift, and before I go deeply in recycling, for the energy shift, CRM is very active also in different, let's say, sectors. We are renewable electricity. We are developing solutions. For example, as I said, we're developing solutions to use metals. And if you have a look on the roofs, for example, now we are developing with ArcelorMittal a solution of integrated PV, let's say, solutions within the steel roof. And in the top face, you have the PV coated there, and at the top face you have the storage. And also this takes in something like a few centimeters. We have also developments in hydrogen We do have, I think, within the next coming 2 months, we have 1 megawatt electrolyzer. We are developing solution for biomass and for, as I said, waste to energy solutions and heat recovery, CO2 mitigation, smart grids, and also, as I said, storage solution like the case I mentioned, let's say, for this steel bat. We are also active in batteries development. Here are also, like I mentioned for others, energy for biomass and waste materials. So we are equipped for conditioning, pre-treatment, carbonization, gasification, industrial CO2 mitigation, CCUS, and synthetic fuels. In terms of hydrogen production, transported user, we have unique testing tools, materials, coatings, and assembly solution for water electrolyzers, pipes, storage tanks, and fuel cells. For renewables, have PVs, solar concentration, wind batteries, smart grids, technology, materials, coatings, tractors, and the user-oriented solution. And I think that one of the developments that were made of the company that built, I think, NOR1 is working with us for the evaluation of this concentrators and so on. Look, analysis over the assessment and integrated system. We just speak about heat recovery, reuse of heat integration, phase change materials, holistic optimization of CO2 and energy efficiency and cost. And the last one, which is on which I will a little bit take more time, this was just to give you an overview, and in for circular economy, I will go a little bit deeper in and give you some details, because this will be the aim of my course itself. And for circular economy, so I think that the circular economy, as I explained, so we need definitely to recycle, and for what to recycle, and we definitely need to provide the economy with materials, and these materials should behave like a primary one, and we need definitely to go over a real recovery and let's say quality of the materials itself to be used within the new manufactured components. And to retain that value, shift is required to more circular, as I mentioned in my introduction, products. So circularity starts at the efficient use of, let's say, of the resource themselves, and then go through lean production, eco-design. I will speak about just say why we have to think eco-design and design for recyclability, design for circularity. Longevity, as I said, also as far as a product could stand for a long time, then it's really important. In order to provide a good, let's say, purpose for the recyclability, you need to know what is the composition of your product. In order you need to follow traceability of the material itself, how it is composed, where it comes from, what are the different materials and elements. I will show some examples later on to see why this traceability is really important. And then when you collect different, let's say, types of scraps of, let's say, secondary materials, you need really very clever sorting of these materials, because it's really important. If you sort well, then if you imagine you are using one of the technologies in order to make a separation of two metals, for example. If you have a mix between, let's say, steel and aluminum that are mixed, then it will be difficult really to use, for example, pyrometallurgy in order to separate them. But if you can sort in a proper way and separate mechanically the two elements, then it's really very important for you to recover both materials in separate way. And the reuse and remanufacturing, as I mentioned, and recycling. I see one. We spoke about waste to energy, and I will speak waste to materials, and we close the loop. Well, in practice, in CRM, we provide pre-processing of industrial residues and end-of-life products. As here you see, this you cannot just take your waste and use it as a raw material. You need to grow through other mixing different material, because they contain the same let's say, element of the same metal, and you can mix them together in order to gain more inefficiency by going through what's called briquetting. And this is really important. If you go just take, for example, the chips from machining shop,
and you try the chips and you put them in your furnace, they will just burn. You will just have a smoke. You will not have any, let's say, efficiency for your process. But if when bricked in, you give a consistency and a density to the material, and when you put it in a furnace, it gives really, you can have higher efficiency. So as I said, we start in size reduction, solid liquid magnetic separation, intensive mixing and agglomeration. I will come in details with all this later on. Resource and efficient metal recovery. We use pyrolysis. In parallel to that, some colleagues are using hydrometallurgy, like Professor Sadoun spoke about, and I don't know which other colleagues spoke already about hydrometallurgy, and maybe better we can just give explanation later on to see the difference between pyrometallurgy is based on let's say on the fusion temperature. So we just put melt and evaporate, and then hydrometallurgy. This is give it really short explanation. Just you work in density. Just to separate the elements by using the density, by leaching or by other technologies. We have different technologies. You need also to protect, sometimes to work with vacuum or with protective atmosphere, reduction and smelting, high yield processes through artificial intelligence and sensors also. Now, design and manufacturing of circular products, lean use of alloying elements, durability, traceability, reuse, and remanufacturing, like I showed in the circles, and added value, materials from secondary resources. I will give an example later on. We managed to produce, let's say, high added value powders for additive manufacturing used in aeronautics with the requirements of aeronautics, but the resource was the aluminum taken from the trash, the waste in our house. As I said, we focus really on high temperature processing. Now, let's say we can work in a lab scale, really in Rackside, to make the proof and first business case and so on, and to assess all technical and economical and feasibility. And then we go through pilot, determination, optimization of most relevant process design data, operating parameters. And this is there's a second business plan, that is a pre-industrial business plan. And then finally, the industrial implementation. So we start from the idea, developing the idea, our partners, and go until implementing let's say the process and the idea within it. Support the pre-engineering investment files and on-site testing and support to industrial ramp-up. Now, keeping the products in the loop thanks to digitalization and additive manufacturing. As I said, it is important that you provide the traceability. You need to know where your metal comes from, the material comes from. And here, for example, you have this tag within the product itself, and within this, let's say this lecture, and you can tag and see you have the identity card of the product itself. We also sort using sensors. For example, we have make the online analysis because you cannot do it manually. So we are developing solutions like XRF, LIBS on image analysis in order to help sorting in a smart way the materials. As said, sorting is really important in order to avoid mixing of elements and selective sorting and dismantling. So before shredding, if you remember let's say the figure where I showed the circular economy, before shredding, we need really to dismantle. I give you an example. For example, for the hard drives are mainly constituted by there's a magnet inside that, there's some electronics, there are some plastics and so on. But if you just go with your hard drive and you try to use it, to shred it in order to reduce to small parts, you cannot do it. There's a magnet inside, and the shredder is metallic. And I will not learn you about, let's say, magnetic forces. You need definitely to demagnetize let's say the hard drive first, and you demagnetize it. You need to go higher in temperature. But if you go higher in temperature, you will destroy the plastics within that. And you need definitely to find the optimum how to demagnetize and without destroying the properties of or the quality of the other let's say the other materials that are constituting your component. Well, this, as I already said, we repair
for example, as I said, yeah, this roll mill cylinders is something like, for example, and it's few tons. The cylinder is few tons. And imagine there is a crack in your cylinder, and in the past, well, just put it aside and just take another one, and which is really feasible because you are losing tons of raw materials. What we do now is just to recover, to create a new surface with the requirements of the steel industry, for example, in order to make rolling of flat products or so on. Recycling topics in a little bit in detail. So the conditioning of waste materials and products to allow recycling without downgrading. Because as I said, if you collect your metals, for example, if your steel is mixed with copper, with aluminum, plastics, and one other, and if you just melt everything together, then your melt has no value, because you downgrade if the main component, the main material is steel, for example. If you put other elements, you downgrade your steel. But you need then you really to make conditioning of these materials in order to let's say to avoid this downgrading and minimize the impact on recycling process. So the oiling, for example, and other activities, because when you collect, for example, scraps from machining shops, these scraps are collected, but the machining shops are using, let's say, oil or water oil in order to make the machining easier. And these materials contain this oil. You need to oil, because if you put all this oil in your furnace, for example, it will generate some smokes which are harmful for the health and so on. And all this really big work on that. In order really to make a proper recycling of materials, you need the proper cleaning, proper sorting, proper dismantling, and so on. And then I already mentioned it, self-reducing briquettes. If you don't, you cannot use the material as you recover it. For example, if you take let's say the chips, as I said, chips, you put them in a furnace, you will generate smoke only, no metal, all will evaporate. Sorry. As I said, thermal treatment of Galva scraps for removal of organic coating, zinc. So we recover zinc because zinc is used in construction in a huge amount. I don't know what about the Middle East, and I think the galvanization here is all many roofs are galvanized and so on. You use Galva everywhere, and you need to recover this because you have a steel and you have only a few microns of zinc on that. And if you just zinc is a few hundred of degrees Celsius to evaporate, and steel is more than 1,600 degrees to evaporate, and not evaporate, to melt even. And then definitely, if you just mix both, you cannot recover your zinc in a proper way. So you need to evaporate your zinc, recover your zinc, and then do the rest. Purification of old zinc, because old zinc has some other elements which are harmful, like tin, like cadmium, and so on. And then you need really to remove this element before recovering this from old zinc. And another topic is also, this is all electronic waste. Electronic waste is one of the worst one, because electronic waste, if you just take one, I don't know, sometimes it happened that one, your phone broke on something, can you have a look on that? You can't imagine how many elements are put together in your telephone. But also a lot of organics, and then you need definitely to have subsequent separation for that. So, as we said, there are two routes to do, and we in CRM we're specialized in pyrometallurgical routes. As I said, we definitely just go higher in temperature and try to separate the elements using this melting point and evaporation. Let's say alternative raw materials from waste. As I said, I will show this example later on for additive manufacturing, e-mobility, and renewable energy production and storage. So with this, try to close the loop for different materials in order to bring them to the There's also one of the important aspects is the modeling and the life cycle assessment of analysis of the process itself, because while you cannot just say, okay, I'm recycling, it's really nice, but it has also some environmental impacts
And you need definitely to evaluate. I don't know what is the time, says Professor Ahmed. So
you can continue. No problem.
Okay.
You can have some.
Okay.
Some,
so
15 minutes, and then we can start discussion.
Okay. So it's important also to know what exactly you're recovering. You need to develop characterization of materials and properties, like physicochemical analysis of complex heterogeneous materials products, that's sampling versus representativity, samples preparation analysis method, recyclability, evaluation of end-of-life products. I will show that later. And secondary raw materials, value in use estimation versus targeted process and product route. Sometimes when people say that, okay, this is a secondary material, my properties, I'm used to work with some metals coming from a given route. When you try to implement the same, let's say, product with recycled materials, then some end users are really hesitating, say, okay, I'm not sure that I will have the good quality, or I don't have the same purity and so on. And we try to demonstrate all this. And when go through certification and standardization in order to give the secondary raw materials a place within the material use itself. In a general scheme, so this is all the separation and sorting, let's say, aspects. This is what I mentioned here. This is the online analysis using LIBS and cameras, or crushing, grinding, magnetic separation for materials to analyze, even in harsh condition, whether high temperature or dust or chemistry. Conditioning equipments, so intensive mixing, dry and filter processing, briquetting. As I said, briquetting is really important, compaction, pelletization, and extrusion. Thermal processing, fixed and fluidized bed, multiple and rotary hard furnaces, a rotary kiln, and also heating under control. These are the facilities within CRM. And the last one is the smelting, high temperature rheometers, induction smelting furnace, rotary tilting furnace, and plasma furnace. Well, I don't know if it's necessary to go in details this, but I will show all this in my courses. There are many equipments, and these equipments are really, most of them are really built in-house. And really, well, some components are both outside, or some, for example, a plasma furnace. Some elements are both outside, but all the engineering is done indoor. And we try, let's say, to have at least industrial scale in order to demonstrate, because we cannot say, okay, in a lab you can make an experiment and you can recover some materials, but if you upgrade any this upscaling is sometimes very important in order to show that it's industrially reliable and you can use it for industry. So I will give the example, as I said, because the title was recovering, let's say, materials from waste, and to make use of it in order to produce a high, let's say, quality components for aeronautic, for example. And this is one of the projects we ran with some Italian colleagues, and that we collect, let's say, aluminum waste from our employees. So what we did, the experiment was that we give a bag to each of our employees, and all the material containing even a very small amount, even less than 1% of aluminum, like some, for example, this chips bags or whatever. As far as it contains some aluminum, the employees bring it to us. So nobody throw this away, because it used to be just thrown in the normal waste bag, which go to incinerator. And we asked our employees to bring all this together, and we collect kilograms, then hundreds of kilograms, then tons, and then we run the experiment, indoor experiment, with the help of our employees, and then we used also some scrap from the industry, because I will show you why we need to have different quality and different types of scraps, because to have this mixture. Though this waste was shredded, then mixed it in order to obtain, let's say, briquettes, and then these briquettes were melted, casted, and then the ingot brick. It is shown here. This is exactly, if you have a look on your trash, you will see many of this. This is classical. You see, you know, this is ships. This is the brackets for aluminum brackets. This is at least nice because this is pure aluminum. This is the aluminum for food, and all this all contains aluminum. So medical, let's say, stuff and everything here, and all this is together collected, and we use some industrial collection also. This is these are ships from machining, and then this all is shredded. It's all mixed. You have that contains a lot of organics, lot of plastics, shredded, mixed, and then bricked. We create briquettes, and they explain why we create briquettes. If we just put the material as it is here in the furnace, it will just go with the smoke. It will cover no metal out of it. We need definitely to have this compaction and have this briquettes. And then this briquettes are, let's say, melted with a mix of some basis aluminum. We need to mix with pure aluminum. We need also to use, because, well, you know, aluminum, when it's brought to something like 600 degrees, yeah, if you leave it on the open air, then it will be oxided, and you will not get out of oxide. Aluminum oxide we don't need to have oxide. We need to have the metal, the aluminum that we use of types of salt in order to cover the surface within the heating furnace, like you see here. So you have here just test furnace, and inside you have the mixture of all this scrap and the aluminum itself, and then finally you recover your aluminum. And the most important of that, so some people were this organic element here, like this plastics here, used to be really a negative point for the recycling of aluminum. But we try to make it, in order to avoid having it like a negative point, and make it a positive point, because these organics are used as a fuel in order to save energy to melt the aluminum. And this also, we have a patent on that. And after this project, I think we managed to produce high quality aluminum. And after that, now we are building, let's say, a factory that will treat 40,000 tons of waste of aluminum. It will be some, let's say, the engineering is working on preparing the factory, and it will collect, let's say, all this kind of waste materials, aluminum, in order to give it a second life, because normally it went to the incinerator. So this is one solution. And then we cast let's say the aluminum itself, and after casting it, we trusted to go through atomization and then try to produce, let's say, a powder for additive manufacturing, and we reused it in order to build walls, and built also other components in order to show mechanically and properties of that are really well, good mechanical properties for the reuse. Now I will conclude while speaking about the paradoxes of the development and innovation linked to this process. If I just, when doing this kind of let's say, of developments and innovation, we have some requirements. First one would be environment and related energy aspect. Second one is the circular economy aspect. The third one is economical aspect and competitivity, because you cannot develop a process and say, okay, I have developed a nice process which works fine, gives nice product, but it costs 4 times what the actual cost. Nobody wants to buy it from you. So this is the problem with today's. This is business as usual. And then one important point is this societal aspects, and all these are linked all together. And now I will just give an example for the wind turbine development, for example. This is how it, since the 19th, let's say, century, and this is the projection of today. I will add some element in this slide, and I will ask a question. Let's say identifying starting point and ending point, and also put in the periodic table. According to you, what is the link between these 3 elements? Can anyone answer? It's a quiz. So if nobody answers, I can go ahead. I cannot access the chat. So if you try, this is really nice because the development is really promising because we are reaching megawatts for the production of renewable energy and so on. But if you make this, let's say the material analysis of this one, you can cover it with just few elements from the periodic table. Let's say some hydrogen, some copper for the organics, because it's some wood-based elements, and you have also some metallic elements. And this you are only using few elements from the periodic table. But if you make the analysis of new generation of this, let's say, wind turbines, you can cover at least nearly 35 elements from the periodic table. So you are using too much elements, which some of them are rare, used here. In order to recycle this kind of components, one component which contains only few elements is easily recyclable than another one which is really complicated. And the second example I'm giving is the bulbs lamp development. So it's nice. We came from the typical CFL1. This is the one which is created by Madison in the 19th century. And we go through development and we reach a LED now. And it's exactly the same. The difference between both, you have something like in the LED, like 42 elements from the periodic table here together. And in this one, it's very simple. You can, let's say with 5 or 6 elements, you can recover the content. And this makes the recyclability. You need definitely, here we are targeting, for example, we reduce the energy consumption, for example, when using LEDs and so on. It's given a nice light and so on and so on. But in terms of circularity and recyclability, it's a really, really complicated product. Imagine you have electronics, you have a lot of stuff within this element. And the last one is linked to waste management. And for this, really one aspect that really, if you remember this waste hierarchy, and in which we said that we need to minimize really the disposal and the landfilling process. But what about all these people that are living with landfills? So if you don't upgrade the human, let's say, kind to work in different levels higher than this one, then it's really, you will create very, very complicated societal problem. So in many countries, people are I don't know what is called in English, in Egypt, the chiffonnier, I don't know the name in English. And in many countries, in Morocco, in Bangladesh, and everywhere, people are living from landfills. But if you extract everything before put into disposal or landfill, then you will cut the life for all this population. And there are millions of people are living from that. So we need also to take into let's say account all this aspect, which brings me to say we have to think really when creating a product in eco-design aspect. Also end of life thinking when manufacturing. What I'm doing with this, because we are buying too many, let's say complex, let's say products, which has nice functionalities, but when it fell down, it becomes really, really harmful for the environment. We need also to have a design for recycling, which is really, we have to take into account that this product, which I'm designing, will be recycled. In order to be recycled, I will have to make it easy life to recycle it. And also design for circularity, but mainly, which is really, this is a human-centered development. And Dr. Ahmed, can I speak now about this, just to give an overview of the syllabus, or
Go ahead.
Yeah. So, okay. Well, my syllabus will be integrated solid waste management, and I will take care of the case of metals. And I will discuss with the other colleagues that are dealing with waste management, like Professor Hassan and the others. And I will give a general introduction on solid waste management, as I said, in collaboration with the other colleagues. well, life cycle technique thinking, sustainability aspect, and circular economy. So metals recovery for recycling and circular economy also. I will concentrate because many of the waste collected within the municipalities, many ended in let's say in incineration. And in incineration, if we think business as usual, in this incineration, there's a lot of metals inside. And I will just explain how to recover materials from this incineration, let's say bottom ash. Details are here. And then I will go for metal recycling. I will treat 2 cases, and I will see if needed that we can add other cases, the aluminum one and the steel case. And I think, there will be, I think, something like 3 months with 2 hours a week, just for the class. I will discuss with the Professor Nawi and the other colleagues when to plan this. And this program is oriented for it could be for bachelor, master, or PhD. That it depends on the qualification. There will be certification. It's also
so, please, just for certification, I forget. We wrote Hassan El Bari, but it's you, huh?
And it will be me, but it doesn't matter. I will because he's at the university. It's me and him, and we will certificate maybe
okay.
in a module. In it doesn't matter.
Okay.
So as you said, the media tools are take the opportunity to thank the SABIC and colleagues from Bahrain for the nice job they are doing, and the learning outcomes. I will be happy if at the end of my course you will be able to understand the requirements of systemic changes and technical possibilities of industrial process and systems to minimize environmental impacts, mainly in many metallic manufacturing sectors, to acquire competence in applying theories to enable the shift from a linear to a circular economy, and develop solutions for metals sustainability, providing economic, environmental, societal, and technological effect. And I would like to thank you so much.
Yeah.
And
before you leave this last slide,
yes,
please correct the email. We have now an email.
Yes, this I will not show them. Then it will in order to avoid that giving mistake. And I really like this one before asking you questions. And this one last, I think 2019, there are a lot of youngs that were really active for climate. And this one was just, I'll take my exams when you take action. So imagine our students will do. So thank you so much.
Okay. Okay, Ustad Salam, after your word, I will show in Arabic one slide, and then we go to the discussion.
I think you can go straight forward.
Okay, thank you very much. Thank you. I will share my screen if you allowed me. It's just one slide. It's as usual. So do you see my slide now?
Yes, it is there.
Okay. بسم الله الرحمن الرحيم الجديد. أولا أشكر الدكتور أحمد رصيلي مدير البحث مطور أعمال وسفير ميثاق المناخ الأوروبي. لقد سلط الأضواء على موضوع مهم جدا، وكما تعرفون استطاع أن يفسر كل ما هو يعني يتعلق بالصناعة من التعدين الحضري إلى المنتجات ذات القيمة المضافة العالية. ودائما السؤال بالنسبة لصانع القرار هم ماذا عن مشاكل النفايا البلدية بشكل خاص؟ من الخطوة الأولى جمعها ونقلها إلى سلسلة من الخطوات من فصلها الذكي ومعالجتها وإعادة تدويرها، بل تحويلها إلى موارد اقتصادية واجتماعية من خلال إعادة الاستعمال وإعادة التدوير. يعني في خطابه تحدث عن كل هذا بدقة، وعن الصناعة في تبارك الله في محل عمله. ماذا عن تقييم النفايا الخطرة والتخلص منها حتى لا تشكل خطرا لصحة الساكنة وللبيئة؟ ونظرتم أنه جاء بهمزة وصل بين الصناعة في الدول المتقدمة وما يحدث عندنا. هناك شعب بكامله يعمل في هذا في المزابل، إذا صح التعبير. الدكتور أحمد راسيلي مغربي العالم، تخرج من جامعة لييج ببلجيكا، وعمل بعد حصوله على الدكتوراه في مجال البحث والتطوير في كل من أقسام الهندسة الكهربائية والفضاء والميكانيك، ثم أصبح مديرا للأبحاث وأستاذا مشاركا في التصنيع المتقدم Advanced. سلط الضوء على هذا الموضوع المثير للاهتمام بعنوان من التعدين الحضري إلى المنتجات ذات القيمة المضافة العالية، ونحن محظوظون بوجوده معنا في جامعة التعلم الافتراضية كمحاضر. اهتمامه الطويل الأمد بسياسة المدينة، حيث هو إنسان يهتم في المدينة التي يسكنها في بلجيكا بهذه المشاكل، يوظف العلوم التي يعرفها في هذا المجال. فهو اشتغل كمستشار بلدي، والخبرة التي اكتسبها في سلسلة التصنيع للمعادن في المواد الخام من نطاق مختبر إلى خطوط الإنتاج التجريبية. إذن السيلابوس بتاعه أو المنهج الدراسي حيتعلم الطلبة الكثير منه، لأن الخبرة العلمية من المختبر إلى خطوط الإنتاج التجريبية مهم جدا، وربما حتى شبه الصناعي، وهذا ما فسره في خطابه. سيمكن هذا الطلاب من اكتساب مهارات عالية في إعادة تدوير النفايا المعدنية metals، وهو قال في الأول أنه متخصص في المعادن وليس في الأشياء الأخرى، إلى منتجات قيمية وفي الوقت نفسه حماية البيئة، وهذا ما نريده. أشكره جزيل الشكر، أشكره أنه وضح بكل كما نقول بالإنجليزية crystal clear علاقة الصناعة ومشاكل النفايا بالبيئة وبالدروس التي سيعطيها في منهجه. وأعطي الآن الكلمة للسيد أستاذ سالم حتى يسير النقاش، وشكرا.
شكرا بروفيسور أحمد. الآن ننتقل إن شاء الله فيما يخص الأسئلة questions and answer or any comments، أي تعليقات أو استفسارات من قبل المشاركين في هذه المحاضرة. أول المشاركين الدكتور محمد المصري. تفضل دكتور ناصر.
السلام عليكم ورحمة الله.
وعليكم السلام ورحمة الله.
شكرا جزيلا، ما شاء الله هذا اليوم التاسع لهذا اللقاء. أنا أعتقد أن الواحد اكتسب خبرات هائلة، وكثر الله خيركم. تعرفنا على عقول عربية مهاجرة نفتخر فيها. دكتور، بغيت أسألك فقط عن قضية الفروقات اللي أنت وجدتها بحكم تخصصك بين الألمنيوم التقليدي وبين الألمنيوم المصنع من الريسايكل مع المواد الأخرى له. إيش الفروقات بينهم؟ البروز والكونز أو نقاط الضعف والقوة، هذه واحدة. ثانيا الكوست، هل كان من الأفضل تروح إلى ألمنيوم تقليدي ولا الألمنيوم المصنع من الريسايكل، وطرق استخدامه أيضا. الثالثة، مدام هذا الموضوع أظن مهم جدا، طبعا في عندنا مشكلتين. عالمك العربي، إما الناس اللي أنت ذكرتهم اللي يشتغلون على قضية أكرمكم الله الاستفادة من الزبالة وبيعها، وهذه تصاحبها أمراض هائلة، أو من خلال للأسف الحفر اللي احنا نحفرها ونطمر فيها المطامر هذه، نطمر فيها زبالتنا أكرمك الله. فبدي شلون نقدر نستفيد من هذا العلم بحيث بحيث أن نطبقه ونقدمه إلى الموظفين في البلدية عندنا بالكويت مثلا في وزارة الأشغال العامة. من ناحية نرفع درجة الوعي عند اللي قاعد يطلع الزبالة هذه أكرمك الله، الريسايكل من البيت بداية، ثم نهاية إلى المصنع اللي راح يقوم بعملية الريسايكل، والفائدة المجتمعية الموجودة. لأن عندنا الآن أحد الطروحات، وأنا اللي مقدم المقترح، أن إحنا ممكن كدولة أكرمكم الله نشتري زبالتك، فإحنا نعطيك مقابل كل كيلو ونص حوالي يعني 50 فلس، حوالي 20 سنت تقريبا، مقابل أنك أنت تعطينا الزبالة بس تكون مفرقة في بيتك، وناخذها إحنا نوديها إلى الريسايكل بوينتس الموجودة، بدل ما تكون مطامر أو محارق، لا نحاول نستفيد منها قدر المستطاع. فأتمنى إذا كان عندك دراسة في هذا المعنى فائدة ممكن نقدمها إلى من يسمى بمتخذ القرار، سواء في بلدية الكويت أو في مجلس الوزراء أو في وزارة الأشغال العامة. وناحية أخرى شلون نربط الآن بين هذه المادة الأكاديمية والشهادة العلمية والتدريب الفعلي على أرض الواقع في المطامر هذه الموجودة أو في المحارق. شكرا جزيلا.
شكرا أستاذ صالح. أستاذ ناصر. May I speak English?
Okay.
Unless there is another question.
I think you can go ahead.
I can go ahead. So yes. I go for the three different points you mentioned. So thank you so much. And for the first one, we tried, as I said, to demonstrate that the quality of primary aluminium and the secondary aluminium is the same. It gives the same property. So because I said some industrials are really sensitive to the source of the resource of the material itself, and they were simply rejecting the secondary aluminiums. And I said we demonstrated that the quality is the same. And in terms of price, the cost of primary aluminium is 95 times the cost of the secondary aluminium. Can you imagine? It's a really high price. So, for example, and there are some alloys of aluminium, for example, which you can recycle indefinitely. For example, this drinking cans, they are based on two alloys of aluminiums, and this you can recycle in a really in infinity. You can you don't downgrade. But time to time you need to add some primary aluminium in order to keep the alloy itself, because there are some other elements. So I spoke about the quality and about let's say the price. In terms of landfilling it has its own rules. You cannot just landfill everything. You need to as it says, this waste hierarchy, and this, for example, this European directive, which should be implemented everywhere, because it protects soil, it protects humans, it protects nature. Because when you put, for example, if you have a look on our trash, it's in the south. I'm not speaking in the north. And people are putting in their trash everything. And with everything, you can find batteries. You can find, I don't know, metals. And imagine the dangerosity of a battery, for example, when put in a landfill without any protection from the soil. So all these elements will infiltrate in the soil and go to the water you will drink in a few years. And this is really dangerous. Landfilling is really, as I said, the last thing to do. And when do it, it has its own rules. And I think you mentioned it already. Before, we need to educate people. If you go to some countries, people are sorting, are selecting what they are throwing away. A plastic is a plastic, a metal is a metal, dangerous waste is a dangerous waste, and everything has its own trash. And you see people here going to on the weekend by their car to the collectors, and the collectors are proposing different, let's say, boxes. And in this one you put your lamp, this one you put your battery, and this one you put and everything is separated. And this is not harmful for the plant. Concerning now, let's say, the collection and incineration, because there is landfilling and there's also incineration, because you cannot landfill. If you go to countries like Belgium or Luxembourg, or small countries like Kuwait, for example, small countries, you cannot landfill indefinitely. You need space to do. You cannot just dig holes and put your waste. When going through incinerators, you eliminate a lot of quantity of but this quantity you eliminate is mainly organics and so on. And I know that in, for example, in the case here of my city, they're trying to avoid having a lot of materials to go to the incinerator. At least when there are some organics, they try to recover some gas or whatever. But when going to the incinerator, what they collect, this bottom ash, they pay someone to collect it. Imagine you pay someone to take the bottom ash out of the factory. But now I will, within my lecture, I will demonstrate that this has a value. It has a value because in this, the incinerator, in the bottom ash, you can find metals. You can find different metals. We even found gold in it. Imagine, so people are, I don't know, the lady was maybe preparing, cooking something and lost some of her bags or whatever, I don't know. We found gold in it. We found other materials in it. I will give a business case on how to make money, if we really want to make money out of that, how we can make money out of that. Normally, when you go to incinerator, you oxide a lot of metals, and this the oxide need more energy in order to recover the materials from the oxide themselves. I hope I have answered to your questions.
جميل. دكتور ناصر، إذا الأمور واضحة إن شاء الله. طيب إذا كان هنالك أسئلة أخرى أو Professor Ahmed, you want to comment also?
Me? Yeah, of course. There always a comment from me. I think it's a general comment. I think the circular economy has to be implemented in every politics, and there had to be a component, and even an important component in the economy of every country, for two reasons. First, because it will bring value to the economy, as usual. And secondly, it has another functionality, which is the environment. So, to take raw material from the nature, from resources, and to translate it into an object, car, wind turbine, and so on, it's one thing interesting, and it will be, and we are used to this, the industry, but to do the same job, to take from the West and to make the same product, it's more interesting. Yeah. Because from one hand, you produce an object, but you do another job, which is the environment, the protection of the environment. And that's what the politics should understand. It's not the same thing. And even you can know after some time it will be taxes regarding carbon dioxide.
Yep.
And I believe a product which is produced from West should be zero taxes product. I mean, if you want to, if a developing country like Morocco, for example, they make recycling and they produce whatever and they sell it to Europe, this product has not to be we haven't to give taxes in order to make recycling as a core stuff for in the country. That's just my.
Yeah, definitely. This will be. I think all this aspect. This is why there's a mix between environment and economy and so on and so on. We try sometimes to show you are protecting the environment and you are making money, guy. Go ahead. Your payback is here, and you protect the environment, you protect humans, you protect the soul, you protect your water you will drink, you protect everything, and you make money. Sometimes it helps because otherwise you could say, okay, I would like to do, but it costs too much to do. So, but definitely, I think it will happen that once the minds will change and people will go ahead with that. I already proposed for Morocco to let's say to go ahead with this kind of let's say helping to implement the circularity and circular economy and so on within some activities, either for municipal waste and so on, but it's not easy.
Thank you, Professor Rassili. Is there any other questions, please, or any other comments? Right. So if it's not, please, Professor Ahmed.
Yes, I think if we go back to your syllabus, what we have to discuss and to find how to do it in the virtual learning university, and how to find the industrial companies in Morocco or outside Morocco or whatever to accept the student, or let's see the people enrolled in our course, to have some internship. And yes. Also it's in the classic universities there is a course and that's it.
No, we definitely need
we have to work that the course is not just to give a course, because you go to internet and you find a lot of material for courses.
Yeah. The interaction between
people. The fact that there is interaction with the guy who is giving the courses, what I call the lecturer and the formateur et le formé in French.
Yeah.
I don't know how to say it, but anyway, we have the student should feel that he has really learned something which is directly related to the application, and he know already a lot where he will go, etc. That is the most important. Otherwise, if we don't do this exercise and to bring the student, the enrolled person, because he can be also someone which is 40, 50, 60, 70 years old.
Yes.
It's not the problem.
Yeah.
We have to come to this. And of course, we have to find industry. They want to help. And we are targeting African people because we want to bring something special to the African.
Yes.
They learn from us. We find from him some way to go to the industry or to make their own. The first talk you remember from Badr Iken is social entrepreneur, environmental social entrepreneur.
Right.
Because we have to make this culture African, our friends in Arab world. This virus, this culture of social entrepreneur to be developed, and recycling is one.
Yes, it's close to people, so it's not something which really everybody has to be let's say affected and attracted by this proposal and this topic. It's really important, but we need definitely, in order to reach this level of attracting industrials for internship and so on, we need at least to run 1 year the university and the courses and see how people will really stick to that, and maybe make after that try to attract also some industrial in order to give models, in order to show that there's some practical cases, direct industrial practical cases. And this we can help to do also later, depending on the topic for sure, and involve them. Why not in accepting students, which will not be very easy. You know, this is the let's say this movement between in one country. It's sometimes difficult. What about this mobility between countries, and it's not easy at all. But we have to work it out, definitely.
That's good. Right. So I think there is no other questions. And we are going to start at 4 with the second lecture.
At 4?
At 2. in Moroccan
Moroccan time, yeah.
Yeah, okay, yeah. But
or in Bahrain time.
it's three in Belgium, yeah.
We have to choose between two options. One is to give the floor to Dr. Kettani from South Carolina. I think he's with us, I guess, but I don't know if he hear what we say or not. That he can start to talk with the student before he starts, or we have to stop
Yes.
and to come back again, as you like. But since he don't answer, then we can maybe stop and come back at 2 o'clock Moroccan time.
Moroccan time. That's right.
Thank you so much.